The introduction of electronic ignition systems as original equipment throughout the 1970s has contributed greatly to the reduction of automotive emissions and the improvement of both fuel economy and performance. At first glance, the ignition systems used by various vehicle manufacturers appear to be quite different from each other, and many mechanics find the variety of test procedures difficult to remember and implement. AutoKnow has simplified this problem by developing test procedures that are common to most domestic and import cars. These procedures are simple, quick, easy to learn and remember, and are particularly useful when sophisticated test equipment is not accessible. This program will show you how to use common testing aids and procedures to test electronic ignition systems for no-start problems. It will demonstrate some techniques to isolate module and sensor problems, and it will identify some methods to help isolate intermittent problems. The test can be carried out with a 12-volt test light with extended leads, a jumper wire, a small 1.5-volt flashlight battery with leads attached, a spark gap tester with an extension lead, a voltmeter, and a tacked well tester. Although most electronic ignition systems may appear to be different, they are in fact very similar, both in operation and in the way the components are connected into the circuit. As you know, in the standard breaker-type ignition system, the distributor points are connected into the system between the coil's negative terminal and ground. In the regular production distributor-type electronic system, the ignition module takes the place of the distributor points and switches the primary current on and off electronically. The distributor pickup tells the module when to switch. The module is connected into the primary circuit in the same manner as the distributor points, that is, between the negative terminal of the coil and ground. In either system, when the ignition key is turned on and the primary circuit is closed, the voltage between the coil negative terminal and ground is almost zero. So a test light hooked between the test points will not light. When the primary system is switched open by either the contact points or the module, the voltage between the coil negative terminal and ground will go to full system voltage and the test light will light. If the engine is cranked with the test light in this position, the light will flash on and off. The flashing light confirms that the ignition primary circuit is being switched, and in the case of an electronic system, that the module is working properly. Now, let's see how we can use this information to diagnose a no-start condition on this 1979 Omni. The first step is to determine if we have ignition at the spark plugs. As cranking the engine with the spark plug wire removed may damage the system, this spark gap tester, connected across the plug wire and ground, provides a convenient and safe method of confirming ignition at the plug. A healthy blue spark shows that the ignition system is functioning and that the no-start condition is due to either faulty plugs, mechanical, or fuel system problems. However, if there is no spark across the spark gap tester, then we do have an ignition problem, and further testing is necessary. The next step is to eliminate the secondary components as a possible source of trouble. This is done by connecting the spark gap tester between the coil output terminal and ground and cranking the engine. A spark here indicates that the primary circuit and coil are working, so the problem will likely be in either the coil wire, distributor cap, rotor, or plug wire. If no spark is visible at the coil tower, then the problem is either in the coil itself or in the primary circuit. To see if the primary circuit is being triggered, connect the leads of the test light across the coil negative terminal and ground. Place the light where it can be seen from the driver's seat. The light should flash or flicker when the engine is cranked. If this does not happen, then the primary circuit is not being triggered. We have now narrowed the problem down to a primary circuit problem, an ignition module problem, or a distributor sensor problem. You can qualify the primary circuit by using a voltmeter to check the voltages at various points in the circuit. For example, where an ignition resistor is used, there should be 5 to 7 volts at the coil positive with the key in the run position, and within 1 volt of battery cranking voltage with the key in the start position. These tests may vary from one vehicle to another, so check your service manual for specific details on the system you are working on. If the primary circuit tests satisfactorily, then the problem has been narrowed down to the distributor pickup and ignition module. Now, to find out which of the two components are causing the problem, separate the distributor connector as shown. Turn the ignition key on and momentarily make and break a connection between cavities 2 and 3. If the test light does not flash, this shows that the module is defective. If the test light does flash, then the pickup is defective. To prove this point, connect a new pickup to the module and, with the key on, pass a thin piece of iron through the Hall switch or sensor. This should cause the module to trigger. The procedure we have just demonstrated can be applied to almost any vehicle with a separate ignition coil, where the terminals and coil tower are accessible. On many GM products, like this 1980 Oldsmobile Omega with high energy ignition, the ignition coil is inside the distributor cap. Therefore, we must use a slightly different procedure. With the engine cranking, look for a healthy blue spark. In this case, the spark does not exist, so we have established that we have an ignition problem. As the high voltage terminal of the coil is not readily accessible, before removing the distributor cap, make the primary trigger check as follows. Connect an adapter to the tachometer or coil negative terminal. Connect the test light to the adapter and ground. Place the light on the windshield or cowl. If, on cranking the engine, the light does not flicker, this means that the primary circuit is not being triggered. So now, let's test the module and pickup. Remove the distributor cap and place it aside. Remove the rotor. Then disconnect the pickup leads from the module. With the test light still connected, place it beside the distributor. With the ignition key turned on, the test light should glow. Next, substituting the test battery for the distributor pickup, connect the negative battery lead to the W terminal on the module. Then touch and remove the positive battery lead to the G terminal of the module. The light should flicker. If it does not, this indicates that the module is not triggering and is most likely defective. Before you replace the module, take a moment to verify that there is battery voltage to both the ignition or B terminal of the module and the coil negative or C terminal of the module. As these readings are correct, we now know that the module is defective. With a new module in place, to verify that the system is now working correctly, turn the key on and hook up the test light. The light will glow. Repeat the trigger check with the test dry cell. Now the light flickers when we create the positive voltage pulse to the G or green pickup wire terminal.